Swayam Prabha. Digital India. Educated India.
Welcome back, students. So, we start with solving some questions that are related to hydraulic jumps or rapidly varied flow. So, this entire lecture will be dedicated to solving some of the basics and a little more complex problems, those type of problems which you encounter in exams like GATE or IES. So, we start with the one problem as below. It says that water on the horizontal apron of 30-meter wide spillway, okay. So, it is 100 feet or that is 30 meter, has a depth of 0. So, 0.06 feet is equivalent to 0.20 meter and a velocity of 18 feet per second, that means 5.5 meters per second. The question is determine the depth after the jump, the Froude numbers before and after the jump. So, this is simple application of the formula that we have. So, if you see in this figure, so the water is coming and it is undergoing hydraulic jump. Okay. And we have to calculate y2, the depth after the jump. So, that is y2, fr1 and after the jump fr2, simple, right. So, we know the conditions here at number 1. So, it is pretty simple to calculate Froude number 1. We will go step by step, the way you should be solving 2. So, in this questions the condition across the jump are determined by the upstream Froude number fr1, that also we have to find out actually, alright. So, fr1 is given by v1 divided by under root gy1, v1 was given 5.5, y1 was given 0.2, you see 18 feet per second means 5.5 meters per second and this is 30 meter. So, the Froude number 1 comes out to be 3.92 and this is greater than 1, which means hydraulic jump will occur. Okay. As I said that the upstream flow is supercritical and therefore, it is possible to generate hydraulic jump. First step. So, in the second step we obtained depth ratio. We had the formula which said y2 by y1 is equal to half into multiplied by minus 1 plus 1 plus 8 fr1 square. Fr1 whole square, which already we found out in the previous slide, was 3.92. Plug these values here. So, what comes out is y2 by y1 is 5.07, all right. Therefore, y2 is going to be 5.07 into 0.2 and that is 1.01 meter. So, this is going to be 1.01 meter, all right. Now, the way we obtain V2 is by equating the flow rate. So, A1 V1 is equal to A2 V2, B gets cancelled out. So, V2 will be V1 Y1 divided by Y2. Y1 was known from before, V1 was known from before, Y2 we just calculated using that Y2 by Y1 equation of hydraulic jump. So, V2 comes out to be 1.08 meters per second, all right. So, therefore, For Froude number at location 2 will be V2 by under root g y 2. V2 we calculated here, this was the reason we were calculating V2 for calculating the Froude number, and this we calculated in the last slide. So, Froude number 2 comes out to be 0.343. So, this means subcritical flow. So, when the system goes hydraulic, when undergoes hydraulic jump, the supercritical flow turns from supercritical turns into the supercritical flow turns into a subcritical flow. So, Froude number is more than 1, and after undergoing the hydraulic jump, the Froude number becomes Froude number becomes less than 1. So, the flow becomes subcritical. So, as it is written here, it is a subcritical flow. All right. Now, we have to also obtain the head loss, that the energy loss. We simply use this equation, total energy at section 1 minus total energy minus section 2. Y1 we know from before, V1 we know from before, Y2 we have calculated, V2 we have calculated. All right, and after substituting in the values, you see the head loss, that the energy loss in terms of head is 0.671 meter. This is the most simplest and the most common type of problems in hydraulic jump, which are the type of questions you also will be expecting in your assignments and exams and competitive exams especially. Now, we go to another question. We say that prove that the energy loss in a hydraulic jump occurring in a rectangular channel is. So, we would try to obtain head loss directly in terms of y2 and y1 if we know the two depths, because sometimes in exams, in the objective type exams like ES and GATE, they simply give you y2 and y1 and ask you to calculate head loss. So, basically what you must do is, please remember this equation. In this particular question, we are trying to derive this, but you must remember this. We will derive this, but in objective type of exam, it is very difficult to derive all the time. So, basically remember this equation. All right. So, the loss of the mechanical energy that takes place in a hydraulic jump is calculated by the application of energy equation, Bernoulli's equation. If loss of total head in the pump is HL, then we can write by Bernoulli's equation, neglecting the slope of the channel, as y1 plus v1 square by 2g is equal to y2 plus v2 square by 2g plus head loss. This is what we generally write. All right. So, head loss can be written as y1 minus y2 plus v1 square by 2g minus v2 square by 2g. Okay. So, this remains same. So, instead of v1 and v2, we write in terms of a common quantity. So, q can be written as v1 by y1 is equal to v2 by y2. All right. So, we write, so v1 so we take out, sorry, very sorry, this equation, erase all, So, this is the same. All right. So, v1 is q by y1. Okay, I just wrote the opposite, q by y2. all right. So, this we substitute here and this we substitute here, and therefore, this q square we take out common, and this is 1 by y 1 square minus 1 by y 2 square, all right, because q is equal to v 1 y 1 is equal to v 2 y 2, all right. So, from equation number 21 C, or we do not need to remember, v 1 is actually q by, yeah, so you remember equation, we are putting v 1 is equal to q by y 1, Froude number 1 is v 1 by under root g y 1. So, this one you see, you go back to the equation 21 C, it is important to show you. So, this one, this is the equation 21 C. So, y 2 by y 1 plus y whole square plus y 2 by y 1 is minus 2 Froude number 1 whole square is equal to 0, all right. So, we can use this y 2 by y 1 here, all right. So, we can simply write y 1 y 2 whole square plus y 1 square y 2 by 4 is equal to q square by 2 g, all right. So, this equation becomes, so this q square by 2 g is equal to this, and we put it here, okay. So, we get H L is equal to y 1 minus y 2 plus y 1 into y 2 square plus y 1 square y 2 by 4 and multiplied by, which will finally give, if you solve this, this is going to give you H L is equal to y 2 minus y 1 whole cube divided by 4 y 1 y 2. An important equation. I think you can, there are other ways of doing that as well, but I think if you should try this one at home, solving this one, okay. So, we go to another basic question which says, if in a hydraulic jump occurring in a rectangular channel, the Froude number before the jump is 10. So, Fr 1 is 10 and energy loss is 3.20 meter. What is the sequent depth? So, we are talking about y 2 and y 1, and then it asks about the discharge intensity and the Froude number, H L or E L, whatever you want to call it, okay. So, to solve this, we will take the help of white screen. So, the things that are given to us is Froude number, or F 1 let us say is 10.0 and energy loss or head loss is 3.20 meter, all right. So, from the formula you remember we had found y 2 by y 1 is equal to half of minus 1 plus under root 1 plus 8 Fr 1 whole square. So, if you substitute minus 1 plus under root 1 plus 8 is into 10 square, and it will give us 13.651, and energy loss using previous question that I asked you to remember EL is written as y2 minus y1 whole cube divided by 4 y1 y2. All right. So, if we say EL by y1 is y2 by y1 minus 1 whole cube divided by 4 y2 by y1. Okay. So, EL we know is 3.20 divided by y1 will be 13.651 minus 1 whole cube divided by 4 into 13.651, and on solving this y1 is going to be 3.20 divided by 37.08 implies y1 is going to be 0.0863 meter. All right. So, 0.0863 meter. Now, y2 by y1 we already know, we have found out y1. So, y2 by y1 came out to be 13.651 implies y2 is going to be 1.178 meters. So, the water level is increasing. All right. All right. So, we have found out y2 and y1. So, we also need to find out Froude number 1, that is v1 by under root g y1. Okay. So, Froude number 1 we already know, 10 is equal to v1 under root 9.8 into 0.0863 implies v1 is going to be 9.20 meters per second. All right. Small q is going to be v1 y1. So, 9.20 into 0.0863 is 0.7941 meter cube per second per meter, and FR2 is pretty simple, V2 by under root G Y2, and V2 can be written in terms of Q by Y2 under root G Y2. Okay. So, Q we have already found out 0.7941, right, and Y2 is, Y2 we found out was 1.178 under root 9.8 into 1.178. So, Froude number 2 is 0.1983. Subcritical flow after the jump has occurred. Okay. So, this is a very simple problem using the formulas. So, you see how this formula of energy loss is equal to y2 minus y1 whole cube divided by 4 y1 y2 is important. Okay. So, there is a solution as always here, you know, I have gotten it typed down. So, sequent depth ratio. So, energy loss using this one. So, after the jump, Froude number is 9.2, discharge intensity, Froude number after the jump. All right, same as we did in the whiteboard. All right. So, another question, it says a rectangular channel has a width of 1.8 meters and carries a discharge of 1.8 at a depth of 0.2 meters. Calculate specific energy, depth alternate to the existing depth and Froude number at alternate depths. Alright. So, in the beginning we do not know what type of question this is hydraulic jump or not hydraulic jump, but this is a very this is a standard problem of open channel flow. So, we should start by writing down what are the things that we know from before. So, to solve this, okay. So, what we know, we write it down. V1 is equal to 0.20 meter, and that is the existing depth. All right. Area is A1 is by1. All right. B is already given, width of 1.8 meter. So, it is 1.8 into 0.2, that is 0.36 meter square. So, velocity V1 is simply Q by A1. Q is given 1.80 and area we know is calculated 0.36, and this gives us to be 5 meters per second. So, the first part is specific energy. E1 is equal to Y1 plus V1 square by 2G. So, Y1 we already know, plus V1, we have already calculated 2 into 9.81. All right. So, this comes out to be 1.47 meter. So, specific energy at 1. All right. So, we have to calculate Y2. So, let us say Y2 is depth alternate to Y1 in specific energy diagram. I would like to remind you, when we were dealing with specific energy, we found out a cubic equation. For a particular Q, there were existing 3 values, right, of Y. One was negative, which is generally neglected, and the remaining one, Y1 and Y2, are called alternate depths. In this question, one is already given to us, and we are asked about the other one. So, the best way of solving this is through specific energy. Okay. So, we have calculated specific energy at one point, and now we are going to equate the specific energy at the other point. So, we write E1 is equal to E2 and E1 is, so E2 is Y2 that we do not know, plus V2 square by 2G is equal to 1.4742, because that is E1 which we have already calculated. Okay, 1.47 actually, you just write it down, it is better, not going into too much. Okay. So, Y2 and V2 is what? V2 is similar to Q by A2. All right. So, Q is V2 square is Q square divided by A2 square. All right. So, we will still write 2.981 into, that is 2G, and then it is 1.8, because all the depth is all, B1 into Y1. Okay. So, this is A square, A2 square, okay, is equal to 1.47. All right. So, if you solve for this, Y2 will come out to be 1.45 meter. you can use by trial and error, or you can, you know, it's not that big a problem. Okay. So, y2 comes out to be 1.45 meter. All right. So, now we know y1, we know we knew y1, now we have y2. So, Froude number at first location is going to be v under root 9.81 into 0.2, that is 3.57. Okay. And for this y2 we need to find out first velocity, right. So, v2 is going out to be q by b y2. So, q is 1.8, b is 1.8 and y2 is 1.45. So, this comes out to be 0.69 meters per second. All right. Therefore, F2 is V2 by under root G y2, and this comes out to be 0.69 into 9.81 into 1.45, this equals 0.1829. So, F2 comes out to be 0.1829. So, we have found using the concept of specific energy everything that was required. All right. So, F1, F2, you know. So, we will close this here now and go to the solutions that which we have solved actually. So, the velocity using the specific energy concepts, the same solution, okay, Froude number. So, this will be of help to you when you revise the course. So, now we are going to solve one last problem of this module, and after that we will end this lecture. So, instead of going to the whiteboard, I will take you through the slides itself, and okay. So, the question is, in hydraulic jump occurring in a rectangular horizontal channel, the discharge per unit width is 2.5 meter cube per second per meter. Okay. So, we have been given, I will explain here only, the discharge per unit width, small q we have been given, all right, and we say that y1 we already know. Now, it is asking estimate the sequent depth and the energy loss, all right. So, the way it is to be done is, you see, we know small q, depth we already know. So, this is the phenomenon y1, v1, v2, y2. So, q is 2.5 meters cube per meters per second, y1 is 0.25 meters already given. So, small v1, I mean v1 is q by y1, which comes to be 10 meters per second, and if we know v1 we can calculate the initial Froude number, that comes to be 6.386. This means we definitely will have a hydraulic jump, because we will have a hydraulic jump, we might, okay, because Froude number is greater than 1. All right. So, we know Froude number at location 1 now, we know y1. So, we will be easily able to find out y2 by y1, since we know Froude number at location 1 by the formula y2 by y1 is equal to half minus 1 plus under root 1 plus 8 f1 square. This we have derived, you remember, and putting in the values, you see Froude number came out to be 6.836, other things y1 we already we were given that it is 0.25 meter. So, y2 will come out to be 2.136 meter, which is called the sequent depth, all right. And now, the last part of this is we have to find out the energy loss EL, and the energy loss EL is given by the formula y2 minus y1. So, we know y2, we know y1. So, we are easily able to find out energy loss just in terms of y2 and y1. So, 2.136 minus 0.250 whole cube divided by 4 y1 into y2, and the energy loss comes out to be 3.141 meter. All right. So, this is the final question of this topic, and with this we finish the module called as open channel flow that went on for 2 weeks. So, in the next week we are going to deal with the pipe flow. We are going to go and see the viscous fluid flow. We will see concepts about computational fluid dynamics, and we will close down with the wave mechanics, which is a typical example of in viscid flows. So, thank you so much, and I will see you next week. Bye.